So, okay, hello, I'm Andrei, and I will be talking about what's new in C# 8. So, for the format of this presentation, um, I will be mainly using the slides, and in the slides there are links to SharpLab code snippets, which SharpLab looks like this. It's a website where you can put code snippets, and on the left there's the C# code, and on the right you can look at the generated IL. For most of the slides, I won't enter the SharpLab demo. I'll just you can use the link at home. I will share the slides, and you can play around in SharpLab. And when the link will be highlighted, I'll enter SharpLab to quickly look at the intermediate language. And I also put all the code snippets on GitHub and a small project to play with the nullability features as well, the nullable reference features. So C# 8 was released in September at .NET Conf together with .NET Core 3.0. And sorry, I'll just stop having candy. I'm a little sick, so I have a candy for my throat. That's better. So for all of the C# 8 features, you need to run on a .NET Standard 2.1 framework, which is .NET Core 3.0 and the latest Xamarin, Unity, and Mono frameworks. For .NET Framework 4.8, there is limited support in the sense that the .NET Framework 4.8 won't have asynchronous streams, indexers, and ranges and default interface members, because these require changes in the common language runtime, and .NET Framework 4.8 wasn't updated with these. And I put here some links to read a little bit about what Microsoft is planning regarding .NET Framework and .NET Core. In short, they are trying to converge all the frameworks towards .NET 5, which will be based on .NET Standard. So to enable C# 8, you have to add in your CS proj the lang version as in the property group. That will now dive in the features. So on the left, there's links to the Microsoft documentation for each features. And as I said, all are supported on frameworks that are compatible with .NET Standard 2.1. And on the .NET Framework 4.8, there's no default interface methods, no asynchronous streams, no indices and ranges. And regarding the stack-alloc features and unmanaged constructed types, span is not supported. So I'm pretty sure the support is limited. I'll start with the first new feature, which is read-only struct members. Just to remember, in order when a read-only struct is larger than int pointer size, the recommendation for performance is to pass it as an in parameter, so that it's passed by reference. And the in modifier says it's passed by reference, but it's read-only. And because it's read-only, when large struct types are passed, the compiler will generate a defensive copy if it cannot, if the struct is not read-only, it will make a defensive copy, so that if the method modifies it, it won't modify the actual passed instance. And read-only members are a helper when the struct cannot be read-only fully, so when the struct can be modified. Read-only members are instructing the compiler what members do not mutate and what members mutate the struct. So in this case, there is a point struct with an x and y property, and there are three methods. Translate modifies the internal state, and distance and toStrings are read-only, and the read-only modifier, which comes with C#8, tells the compiler, hey, this is not going to mutate the internal state. And you can see in class C that there is a read-only call which does just a toString, and there is a mutate call which calls translate. And you can, if you'll open the snippet using the SharpLab link, you'll see in the intermediate language that for the read-only call, there is only one local variable which gets generated by the compiler, which is a string, which is the result. And for the mutate call, there is a value for the parameter, and basically this is the defensive copy which the compiler generates, and then there is a value for string for the result. So that's why the read-only modifier is useful to help the compiler avoid generating defensive copies for structs. The next feature, and by the way, if you have questions or you want me to go slower, just let me know. The default interface methods were added, and basically you can now declare the implementation of a method on an interface, like with an abstract class. But now you can do it on an interface so that the consumers of the interface can update their APIs, and they can basically pick what they want to implement, and otherwise it will fall back on the interface implementation. And the diamond problem, which exists or existed at least in C++, I don't know the newest versions, which is because of multiple inheritance. This is detected by the compiler. So if there are multiple interfaces, like in this case, and the compiler doesn't know which method to call. Let's say there's an interface I point and two interfaces which inherit from them, and then point implements two interfaces which implement the same base interface. If the compiler cannot tell in the program which interface should be used, it will just not compile. So the C# team tried to do that. And in this case, point does not implement the interface method. It does not implement foo. So when the point class is instantiated, we cannot write point.foo because the method is not implemented on the class. But then if it's cast to the interfaces, it will be able to be called. And in each case, it will call the implementation of the interface. And
can I get back to previous declaration of the interface?
Yes.
So when overriding in I.A, I.B, you don't have to specify any modifiers like with overriding methods in a class, like with override, with or whatever. So you don't have to specify anything with that. You just override the method.
Yeah. In this case, the squiggly line is because the compiler will complain and will tell, hey, if you're overriding the method, so you should add new. So I can actually go on SharpLab for this one. So in this case, it will say I point foo hides inherited member foos, and use new keyword if hiding was intended. So this is just a warning for in case the developer doesn't realize it's hiding the base implementation. But yeah, it's no override or something. either hiding it with a compiler or warning or with the new keyword. So that's about let's say the basics of default interface members. The next C#8 feature is switch expressions, which they basically look like this, which is it's just an expression with a single return value, and the two methods are equivalent, and just the first method has a body and the switch statement, and each case returns a value. And in the case of a switch expression, it uses the arrow case, the arrow syntax and it just returns an expression. And the discard operator is used for the default case. And the switch expressions is just a way of clearly expressing that there's only one return expected from a switch, and the runtime will throw a exception if the switch is non-exhaustive. So if it does not provide all possible values, it will throw an exception. In this case, it does have the default value at the end. And this is just a method from our code base. I work at SonarSource and we work with Roslyn, and we basically have some code analyzers, and for the .NET we use the Roslyn framework, and we get the symbol from Roslyn. And in this case, we have many such such methods which just check the kind of a symbol and or the different properties of what Roslyn gives, and based on that we do different we do different actions. But this switch statement is clearly a candidate to be refactored with for the switch expression. Another change which is related to switch expressions and blends with switch expressions very well is adding more patterns. So and the idea is to have more readable code. And for our examples, I just added some simple an enum and an address which has two properties, a country and the code, and the person that has an ID, a name, and an address. So it's straightforward. And the tuple pattern can be used to switch on a tuple. So the tuple is created ad hoc, and then in this case we're checking the values of the country of the person and the place the person works, and if it's in the person lives in Switzerland and works in Switzerland, it's a Swiss insurance. If it lives in France and works in Switzerland, it's either a Swiss or a French insurance. It's just an example. And you can see that the last tuple pattern uses the discard operator, which means anything with anything will just return empty. And by this, the switch expression is covers all the possible cases. So this is the tuple pattern and can be used to write more expressive code. The object pattern, or also called property pattern, it allows to basically pattern match on the object on the object properties, on the object shape, let's say. So in this case, this method is anonymous Swiss returns if the person has a name, a null name, and it returns true if the person has a null name and the address is in Switzerland. And you can see it's recursive. This was another addition with recursive patterns. So inside the let's say, decomposition of person, we decompose address as well, and then inside we use the constant pattern, which checks if the country is equal with Switzerland. And the second syntax does exactly the same, and you can see here that um, we can also use just empty curly braces to specify that the object is not null. So this is a syntax sugar. Previously, we could have done p is null and then put the exclamation mark before to negate. But now it can be done cleaner, and it's exactly uh, the same functionality written in two ways. Um, Then for the next pattern, I'm gonna use a point class which deconstructs. This deconstruct was added in one of the C# 7 dot. I don't remember 7 dot what version, but you can you can add a deconstruct method on a class, and you can just transform that method in a tuple using this. And the deconstruct pattern, or the positional pattern, does this. So we switch on the point, and because the point has the deconstruct method, uh, this we can switch on what it gets deconstructed into. So if in this case, if the x and y are 0, 0, it will return origin, and then we can check with when clauses um, the what it gets deconstructed, the values of the deconstructed of the properties, basically, which come as a tuple. And the cons of this using the deconstruct pattern is that you have to know the order in which it gets deconstructed. So in this case, it's an x. The first one is x and the second is y, but you can imagine you can have a big object with 10 properties, and if you want to deconstruct 10 properties, you have to know their order, and it's less easy. And the same switch expression can be expressed with the property pattern. And the property pattern, you can just do exactly the same, but specify the properties in whatever order you want. And like I find this better. So it's doing the same thing in two different ways. And it's like with the other patterns that were introduced, with the constant pattern, which was introduced in C# 7. It makes code more readable, and this makes C# nice to work with. And I put a link on the initial slide with property patterns to the Microsoft um, documentation, where they have, let's say, complex cases. In this case, there's an object which can be different. It can have a different type, and there is a switch done based on the type, and then there are nested switches inside. And you can imagine you can write quite declarative code like this, and yeah, it's pretty nice. So you can do recursive pattern matching, and you can do embedded switches, and everything is fairly straightforward to follow, because you know it's just going to be one return value from the whole expression. That's about patterns. Another change in C# 8 is using declarations, and it's just a syntactic sugar for instead of having the using statement. And I'll just open it on SharpLab, so you can see the before it's a using statement, and after it's the using declaration. And in both cases, it's the same intermediate language. So the using statement uh, gets generated into a try finally, and the finally calls the dispose method on the file. And So that's the using statement, and then the using declaration, it's literally the same code. So it's a try finally, and then in the finally, the dispose method is called. So it's just a syntactic sugar. Static local functions, this is another performance improvement in C# 8 to help the compiler optimize the intermediate language. So uh, with local functions, in this case, the local function captures the parameter, and you can capture variables as well. So the problem with this, so I can also add a local variable here, and then return number times x times y. And the problem with this is that the compiler, because these variables are captured by the local function, the compiler will generate an internal class, this display class 00, which has two public fields. It's a private nested class, which has two private fields, number and x. And then when uh, the static the multiply local function gets called, it gets passed one parameter, the private class, the display class, and then it uses display class, the fields on the generated private class, and using static local functions is just a way to tell the compiler that you want to optimize. So the local function can be static. It doesn't need to capture any variables. It doesn't need any internal private class. So in this case, if we pass number and x, you see there's no private class generated anymore, and there's no capturing variables, and the internal the local function will be passed the two numbers as parameters, and this just is more efficient. So there's all the overhead of um, having captured variables and having this state stored in a private class goes away. So it's just a way of helping the compiler optimize code. Um, Another C# 8 change is disposable ref structs. In short, ref structs were added in C# 7.2 for contiguous memory access, so they're always allocated on the stack, and boxing is not allowed to avoid allocating it on the heap, and it cannot inherit from an interface. These are by design on the ref structs, and the problem is that they cannot be disposable because of this, because they couldn't be until C# 8, because they could not inherit from iDisposable. And what the C# team did was, okay, if a ref struct has a public void disposed, it will use it as a to make it a disposable struct. So it's kind of a hack to avoid having to inherit from iDisposable. It is on SharpLab if you want to look at home. The link is here. I won't go into details into this one. Asynchronous streams. So before this C# 8 change, if you wanted a synchronous like stream, in this case we open a file and we return an IEnumerable of tasks, and then in the consumer, this is the consumer, and we enumerate over the IEnumerable, and then we await the data. The only problem with this is that the the method signature is kind of dirty. You have to specify task, and you can imagine that it can become more complex if you have multiple tasks. And what this code becomes in C#8, you can ignore the result because it's not used. I didn't update the snapshot, the screenshot, sorry. So the result is not used anymore. The return type is async enumerable. So this type comes with the common language runtime, and it's not supported in .NET Framework 4.0, 4.8. And now you can just specify, okay, this method is async, and it returns an async enumerable of string, and then this line, okay, is awaited and then is yield returned, and the await for each was added to the language, and you can await for each for the data that comes from an async enumerable. So this is basically uh, making code more readable when you need to do asynchronous operations on an enumeration. Another sorry, another change was adding indices and ranges, which basically arrays are zero-based index, so they start from 0 to 9. But if you want to reference the end, you have to say, for example, words of words.length minus 1. And the change in C#8 was adding indices, and you specify it with a caret, and caret 1 means words.length minus 1, caret 0 means words.length, and so on and so forth. And by doing this, you make again you make the code more readable and less error prone. So in this case, uh, words caret 1 means is the same with words dot length minus 1, and ranges specify a range of indices. So in this case, dot dot contains the all the words, and then caret 2 to caret 0 contains the last two, and the end is not included. So here is until 4, from the beginning until index 4 excluded, and words of 6 is starting from index 6 towards the end of the array. And what's important is that this does not copy this does not copy, it does not create a new array, it does a slice. So using ranges is very let's say optimized. You don't create new references, it just reuses it. Inside it references the same array. And I put here a link to get subarray, which is the compiler runtime instruction in the common language runtime. You can look at it it basically says it does a slice of the array, and it does not create it.
If the order of the array is modified afterwards, what I see from what I get from what I get from the slice, changes as well. Is it updated according to the order of the words within the original array?
I haven't tested that,
Okay.
but we can play with that at the end. So I have them. I have all these snippets in Visual Studio, so we can play at the end. I haven't done a test. That's a good question. Um, the next uh, the next feature is null coalescing assignment. So this basically question mark equal means assign if the value on the left is null. So previously we had to do an if singleton is null, then assign it new before and return the singleton. And what this null coalescing assignment does, you do the same thing in a single instruction. And basically if you look into the intermediate language that gets constructed, it's like doing a branch. It checks the value of null, and if value is not null, it does a jump here at return, and otherwise it continues to assign it default. And yeah, this is another syntactic sugar added in C#8. And in some other changes are unmanaged constructed types. So previously, if you did a struct with a type argument, it could not be allocated on a stack. So it would be always allocated on the heap. And starting C#8, you can allocate. You can do this. You can stack a lock. This struct which has a type parameter, and here in the IL, all these instructions of creating it are on the stack. Basically, this is why I wanted to show in SharpLab. So previously this wasn't the case. You couldn't do stack alloc with such a struct. And another change was to allow stack alloc to be called inside another expression. So previously this wasn't possible. Previously this had to be stored in a different variable and then do numbers index of any something. And you can see the difference in this case. It's an array which is heap allocated. So this is how the intermediate language looks like when it does a heap allocation. It does a new array, and then these are the instructions when doing the stack allocation. It's totally different instructions, and it's only doing it on the stack. So it's more instructions, but it's because it's contiguous memory access, it can improve performance. So that was some performance improvements for how to manage memory. And these are all the features. I went the only other feature is the enhancement of interpolated verbatim strings. So this is just means that now when you want to use an interpolated verbatim string on multiple lines, you can either use $@ or $, and previously the $ had to only this syntax was valid, and now you can use either. I didn't add a demo with this because it's a small enhancement, but it makes life better. And just to recap, the features which need common language runtime types, new types, which are default interface methods, asynchronous streams, indices, and ranges, and also the working with stack allocations, which work with span-t. These are not supported on .NET Framework 4.8, and all the other ones are. So you can use, if you update to .NET Framework 4.8, you can use all the other compiler features, including the nullable reference types, which I will start talking about now. So the thing is, the inventor of null, Tony Hoare, named null the $1 billion mistake because of null reference exceptions, basically, null pointer dereference, that I think everybody in this room had a problem with null reference exceptions. And nullable reference types are a way of having less null reference exception. but that doesn't mean that we'll stop working with null. It just means that now we'll be able to say in the programs that we write when a reference type should never be null and when a reference type can contain null. So, and doing this, the compiler can help us write better code. So it can warn us, hey, this is null, please do a null check before. So until now, the compiler wasn't doing this, and you had to use some code analyzer. For example, in our own Sonar C# code analyzer has a rule that helps you detect null reference exceptions in your code, but otherwise you couldn't find this easily. And now the compiler will have the same functionality. So in short, just until C# 8 and including C# 7, reference types are implicitly nullable. Any reference type can be null, and you can't have a non-nullable reference type. And value types are implicitly non-nullable, but you can declare a nullable int or a int with the question mark, which makes it a nullable value type. So this was introduced in C# 2. And now, starting with C# 8, with the nullability feature enabled, by default, both reference types and value types will be non-nullable, and we can declare explicitly when we want a reference type to be nullable by adding the same question mark, with the mention that there is no common language runtime representation of a non-nullable reference type. So once the code gets compiled, any reference type can still be null. Even if it's declared nullable or non-nullable, at runtime you can still have null. The only difference is that now, so I just said this, that a non-nullable reference type can still be null. The only difference is that now our code can express when it should not be null, and the compiler can warn us when we're doing bad things. So when we're doing a dereferencing a field on an object, and if the object is null, the compiler will warn us. And the compiler will emit a warning when possible, when it detects this. And also another change is that at runtime the compiler will, not the compiler, the runtime will specify what is dereferenced and what causes a null reference exception, because usually with null reference exceptions you don't really know at runtime if you get a customer support ticket, hey, your program is crashing with a null reference exception. It's a generic null reference exception, and unless you have a reproducer, it's quite difficult to investigate. But now the exception will have, in starting C# 8, will have this metadata, so we'll tell the full namespace of the class and the actual method that causes the null reference exception. This is just some terminology in terms of nullability. So non-nullable reference type means that null cannot be assigned. If in the code null will be assigned to a non-null reference type, the compiler will emit a warning. And non-nullable reference type means that, okay, it's safe to dereference without doing the null check. So compiler won't warn if you do a dereference on a non-nullable reference type. Nullable means basically what we've been working until now. Null can be assigned. We can assign null. The compiler won't complain. However, if we dereference a nullable reference type without doing a null check on it, the compiler will emit a warning. So this will help us. find it early. Oblivious in this nullability terminology means just what was before C#8. So there won't be any warnings, and this oblivious nullability is when the feature is not enabled. And unknown means that, okay, the compiler cannot tell if the type is nullable or non-nullable. And another terminology is nullable annotation context and nullable warning context. So it's two contexts the compiler runs with. If the nullable annotation context is enabled, you can use annotations to declare reference types as nullable. If it's disabled, it's just until now all reference types are uh, nullable, so it's just what we're used to. And the nullable warnings context, it means that the compiler will warn in the build, will warn or not, but using flow analysis will tell us, okay, you're dereferencing the null context. And these two contexts can be used together or can be used separate. So in the CS proj setting, in the property group, you just have to, to enable the feature, you have to add nullable and one of these four options. Nullable enabled means both annotation and warning contexts are enabled. Warnings means annotation context is disabled, so just use compiler warnings, and the compiler will use static flow analysis to determine the null state of any reference, and the state can be null or may be null for the compiler. And annotations means that warning context is disabled, so you can use the annotations in your code to specify the intent, should this reference type instance be nullable or not, but the compiler won't emit warnings, so the build will be warning free. And disable is the default, so it's just what we're used to. So if by default it's disabled, you have to explicitly enable it in your code. And this can be done via directives in the code as well. So when using C#8, even if at project level nullability is disabled by default, you can enable it only in a certain file, or you can, if it's enabled by default, you can disable it. And you can also disable it and enable it on portions, so using restore. And you can also disable just warnings or just annotations. And this is useful when migrating. So the recommendations from Microsoft are for existing projects, to enable nullability for all the project, and then do a change on all files to disable nullability for all existing code, not to have warnings. And then when you add code to the project, at least you will use the feature. And then one by one, using the directives, you can transform your code base to use the nullability feature. And I put here a sample PR on GitHub, a link to a PR from a library, Time, which is written by John Skeet, who's quite active in the C# area. And he, at the beginning of the year, he updated his library to use the nullability feature. And you can check this link to see the steps and how he enabled the feature on the full project. With the mention that on Time, he was already using some JetBrains annotations to specify for the APIs if it should return null or not. So it was easier for him because he already was expressing this intent in his code. So this is a link to the Microsoft tutorial on how to upgrade to nullable reference types. And here I just put, okay, we have the same enum, country, address, and customer. And basically Here the address is explicitly, so name is not nullable, and if I comment out the constructor, I will get a warning, a compiler warning, non-nullable property name is uninitialized, consider declaring this property as nullable. You can see here at the top that I enabled nullability for this file, so nullable is enabled. And I can add a question mark and, oh, sorry, not on name, on the type. I can add a question mark, and by this I tell the compiler, okay, this is nullable, and if it's initialized, the compiler won't complain because this string is not nullable. So at the instantiation, I initialize name. Now I can make string nullable as a parameter, and now there is a compiler warning that it's a possible null reference assignment. So I'm possibly assigning null to a non-nullable reference type. So again, either I make name nullable, or I force it to be not nullable as a parameter. Now, again, in the customer, if I now create a customer and I pass null, I get a compiler warning, cannot convert null literal to non-nullable reference type. And again, if I mark the intent on the constructor, the compiler won't complain. So, and you can see that all the code base needs to be updated because all these warnings propagate as the code base is changed with nullability enabled. And in this case, if I have address which is nullable, and here I dereference it using doing the null check. So if I remove the null check, and okay, I get a compiler warning, the reference of a possibly null reference. So these are the benefits of using enabling the nullability feature, because the compiler will just tell us, hey, address is nullable, you are dereferencing it, you might have a null reference exception. And again, if I add the null coalescing operator, it won't complain. Now, if I store it in a local variable, again, the data flow analysis will follow it. So in this case, it knows that the address is nullable, so it complains at the null reference. And if I do a null check inside the if, it won't complain because here it's safe, so it's marked. Again, it knows also. Well, I already showed this. Sorry, already showed this. So on properties or on local variables, the compiler knows how to follow. And the last new operator is the null forgiveness operator, which is an exclamation mark, and we tell the compiler, hey, leave me alone, I know this won't be null. Now, this can help when the compiler has false positives, but you can imagine that it's not really recommended to use the forgiveness operator, because it's basically telling the compiler, hey, leave me alone. But we can do that with nullable disable, and we can do the same. So if we really want to avoid warnings, we can either use a directive, or we can use the null forgiving operator, hoping that at the runtime we won't get a null reference exception, even if the compiler says we might. So this is one part of the problem, our code base. However, even if we enable nullability on our code base, we still use APIs which come from C#7 or predate C#8. So in this case, we will still receive null from libraries, and the public ABIs of libraries have to be migrated and annotated. So there are specific annotations on libraries that tell, okay, this call can return null, or this call will never return null. And for the core lib of .NET Core, which on sorry, on the Microsoft, one of the links I put, they say that this is 20% of the .NET Core shared framework, and it has been fully updated. So starting .NET Core 3.0, the system.io, system collections, all these namespaces are annotated. So now we can tell from just reading um, the declarations of interfaces if the library method can return null, or it will never return null, and we can use that, and the compiler can use that to help us write safer code. And the API annotations are these: allow null, disallow null. This is for input arguments. So we can mark arguments as disallow null or allow nulls, and if I put disallow null on an argument and I pass, if a library has disallow null on an argument and I pass it a null, the compiler will warn me because the library is not expecting null, and it might throw. Maybe null and not null are annotations for return values. So these are used on method signatures to say that it will never be null, or it might be null, the result. And there are also some annotations which are conditional, basically. And I'll just open another demo. So in this case, you see that here by default the value is allow null. So this is the same as writing allow null, because this has been the behavior until now. So by default this allows null even if screen name is non-nullable. The interface allows null, and it falls back. It has a fallback. But if we remove this fallback, well, I was hoping to get a warning, and it says non-nullable. Okay, this is a different warning because it's not initialized. Okay, I'm a little bit confused because I was expecting to see a warning. Maybe if
You can initialize it, no?
yes, I can. You're right. I can just initialize it inline, and then it says use auto property. But okay, I'm confused. I was expecting the compiler to complain that I'm setting. Okay, it says screen name is not null here, but this. Okay, let's move forward. I'm a little bit confused about the behavior. And this in this case, we say disallow null. So the
But
input.
there you have the string. Maybe it's the string that is not nullable. You have public string name without the question mark. There.
Yes, but that's the thing. You can allow null values, but you can allow null, but you can
But
allow
by
null.
default, the string will be not nullable. No.
Default, the string is not nullable. Yes. So in this case, the string is not nullable, and it returns a not nullable.
Okay.
If I make it nullable, I will get a warning because yeah, by default it's not null. So uh, uh, eh, okay, so if I'm saying not null, here it says the compiler complains possible null reference return, so it warned me, and this is the default. Because screen name here is nullable, and if I make screen name not nullable, uh, I would have expected here that value should it should have given a warning because I am allowing null as a value. Um, so disallow null in here, I am disallowing null as an input, even if the type allows it. I am disallowing it, and okay, I can still be defensive, even, but in this case, I am throwing an argument exception. So, and I am marking the API with disallow null. So I'm warning the users of the API, hey, null is not allowed, so do it on your own risk. If you assign null to review comment, I will throw. So it's just expressing intent. And you can see that here the return value is not nullable, but the API can allow null, and it should treat it. Otherwise, it will end up being messy. And here the API says, okay, the result can be nullable, but I don't allow null. So you can have all these combinations. Now, maybe null is for the return value. So here I have, sorry for, so I have two arguments. I'm basically doing a find on a sequence and with a match predicate, and I'm returning first or default, and first or default can return null if it doesn't find it, and I'm saying this, okay, it may be null. Now, if I, instead of maybe null, I'm putting not null, again, the compiler should tell me, but it does not help. But again, in this case, I'm just telling the caller what the value will be. It may be null or not. And here I'm saying not null because I'm doing a first or default, and then if the return value is null, I'm just returning default. And the here another one, this is a conditional annotation, and the is null or empty method, which is on a string, is marked inside its in the library, is marked not null when so the declaration is not null when uh, false. So basically, if is null or empty returns false, the input is not null. And this just tells the compiler that, okay, if is null or empty returns false, I'm checking here that it returns false, the value of the parameter is not null. So this is just an instruction for the compiler that here it's not a dereference, a null dereference. So there is no warning. If I don't do is null or empty, here the compiler says dereference of a possibly null reference. But because the is null or empty method is annotated with not null when false, the compiler doesn't emit a warning. Now, if I remove this, the compiler knows that, okay, is null or empty is true, so this not null when false is not relevant anymore, so it will say, it will give an error. So, okay, sorry, I tell the compiler to be okay. And now not null if not null, this get top level domain says, okay, my return value, if my parameter is not null, is not going to be null. And basically the signature says, okay, this can be null, but the compiler knows that, okay, if now I can make, let's say, another method. So test2, and I get an input, and I do a return get top level domain with the input, and I return the length. And in this case, it says dereference of a possibly null reference because input is null. Now, if input is not null, I don't get a warning anymore because of this annotation on the method get top level domain from full URL. So in short, this is how the migration in the whole .NET ecosystem has to work. First, all the library maintainers have to update their APIs so that when you use an API, the compiler can tell, okay, this can be null or it won't be null ever. And then the consumers of the libraries will have to update their code base. And
just a question, maybe.
Yes.
Back to this, if you look at this shortcut. So when the magic is happening, is it happening at compile time, correct?
The magic of warnings is happening at compile time.
So there's no checks done at runtime.
No. So at runtime, we can still have null reference exceptions. So all this nullability feature is just at compile time to help us write safer code. But at runtime, we can still have null reference exceptions with the mention that they will be a little bit more helpful, but because they're going to say what caused the null reference exception, but we can still have them. The only thing is that by annotating the libraries and using the nullability feature in the code base, it will be less likely to have null reference exceptions, but they can still happen at runtime. And these are just features for the compiler to give warnings at compile time, basically. And yeah, as of now, the compiler just gives warnings, and basically people can ignore them, can still build with warnings. But we can imagine that, I don't know, sometime, probably not when .NET 5 will be launched next year. So in autumn 2020, .NET 5 will be launched, and the recommendation from Microsoft is to update the code bases to use nullability until the launch. But we can imagine that at .NET 6, the compiler will give an error instead of a warning. So at some point in the future, this might transform in actually a compile error. But I don't think it's going to happen too soon because it's going to take time to update all the libraries and everything. Yeah. Um, and as a bonus, I think it's okay. Um, so we have this rule: null pointers should not be dereferenced is in Sonar C Sharp, and I just wanted to compare what the Roslyn compiler gives and what the Sonar C Sharp gives, and um, so
Sorry.
yes,
So if we use a library that has not been annotated,
yes,
then we will get maybe a bunch of false warnings.
um,
If we require, let's say, that the input is not null.
yeah. For this, I haven't tested how it behaves, but I guess that if we use a library which is not annotated, yes, the compiler will just say this is nullable. So yes, it this is why it's important for library maintainers to update their APIs, because otherwise this feature won't really be very usable. And this is why you can on the project level you can just enable annotations. So to avoid having all the false positive warnings, you can just start using the annotations in the code, and this will help at least. This will make the code more readable. The intention will be clearer. Okay, this shouldn't be null. This should be null. And then when the libraries will slowly move to use the annotations, the warnings will be able to be turned on.
Because if we disable and we have the annotations, we will get some error. Or if
If
we disable, let's say we disable at project level, we set it to disable,
yeah,
the nullable, then we use the annotations in some.
it won't it won't compile. It won't compile. So
say unknown.
yeah, so for example, I don't know. Let's open this and say I have string s equals null, and uh, okay, and if I move, I have enabled on the project nullability, but if I disable it, uh, and I try to build, it should not compile.
Annotation for nullable reference type should only be used in code with a nullable.
Okay, so it's just a.
Yeah.
Oh, yeah, okay. The annotation for nullable reference types should only be used in code with nullable annotations context, yeah.
Okay.
So, but this is a warning.
Yeah.
So it still compiles, but it gives a warning.
Okay, so it's just telling you you're using new features when you disable them.
Yes.
In a context where they are disabled.
Yes. Yeah. Yeah, because I'm still using, I'm still using the 8th version. If I'm gonna use a different version, it won't compile. But because I'm using 8, it will compile with a warning. Yeah. Okay. And on
Now don't forget to change your project.
Yeah, it doesn't matter. It's just a play project. So and for the nullability, I just opened like a file with it's a test file with lots of nullable dereference. So in this case, object O is initialized to null, And I'm just gonna what I did just to specify all the steps. So it's a .NET Core app 3.0. Lang version is 8.0, nullable enabled. So warnings and annotations are enabled. I've included, just to compare the compiler versus Sonar C#, I've included as a NuGet package, and it's free to use. And in the validation rule set, I've just enabled, I've just enabled the warnings for, okay, I had them. Okay, I don't want these warnings, and I only wanted the nullable. So yeah, damn it. I wanted to enable just the possible null reference assignment. So, oh, okay, the reference of a possibly null reference. So this is 8601. I'm just gonna disable all the other warnings, and 8601, I'm gonna enable it. I'm gonna enable this warning from the compiler, and then I did the same for S2259, which is the null pointers should not be dereferenced. This is just to have only these warnings in the build, and I should have less warnings now. Okay, I have only 134 warnings, and okay, even less, 82 warnings, and I'm just gonna move them, uh, look at them line by line, so that we can see when one warning triggers and the other doesn't. Okay. Okay, these are different warnings. These are, okay, so we can start here. So in this case, you can see this warning comes from the Sonar C#, which says that, okay, foo is null on at least one execution path. And I don't see the...
I think you didn't choose the dereference, you chose the use as assignment or something like that.
Yeah, probably I didn't choose the right warning on the Microsoft side. Null pointers should not... Okay, this is... Sorry for that.
Dereference.
Okay. Yeah, you're right. It's 8602. Yeah. So rebuild. Okay, now we... Okay, so you can see that in this case, S is null, and there's a for loop which modifies S. And that's what the data flow analysis, it realized that, okay, even if we modify S inside a for loop, here S can still be null. And both the compiler with CS8602 and the code analyzer S2259, both of them find this reference. And you can see that there are, more complex cases. Here there is is just a for each, and x is compared to null. So you know that x is null inside this for, and if you null dereference it, both the compiler and the analyzer will find it. So in most of them, there's pairs. However, here, this only the compiler finds it, so Sonar C# does not find it. And string is assigned to null, and then here at yeah, this is a field, and x is assigned to s, which is null, and the compiler can tell that this field is now null, and the Sonar analyzer doesn't tell. I think it's because we don't follow fields. And it's the same here. The compiler tells here that S1 is null. And why we don't raise? We don't raise because this code is unreachable, because this guard is validated not null attribute. Basically, we follow these attributes from, I think they're from a JetBrains library, and we say, okay, this method will validate this string, and this is actually that code, and we don't raise on that code, on unreachable code, and the compiler in this case raises. And yeah, here we can see pairs. Again, here it's the same thing with fields. And apart from that, both for most cases, both the compiler and the analyzer will tell. And the compiler is a little bit more noisy, so and in sometimes it's more precise. But for most, you can see that it's pretty reliable, because for most cases where our analyzer detects a null dereference, the compiler detects it as well. So that's encouraging for the compiler. And then there are cases, yeah, these are the field reference, which we don't really support. And we don't support fields. We mainly track local variables. And here it seems that here we find it and the compiler does not find it. So in this case, we do track the field, and that's because this null const, this is a const which is null, and apparently we find it, but the compiler does not find this constant. So this is a constant which is set to null, and we trigger the analyzer. Sonar C# finds it, but the compiler does not. And anyway, I'll stop here because it's kind of boring of doing this. We'll have to do it to, to improve our analyzer, but or at least see what we're missing. So to conclude, we can now express whether a reference type should never be null if we enable this feature, and we'll still have null flowing around, but as the whole ecosystem will update using annotations for libraries, we'll just know better when something is null or not, and we'll be able to write safer code. yeah, that was it. That's my last slide. And I think there was a question from I think you asked at some point, but I don't remember. Okay, it was a question
I was about the slides.
about the slides. Yeah, so the question is whether we do us. Okay, so we have indices and ranges. I'll just make it as startup project to easily run, and um, we have this indices and ranges M. So um, we have these words, and the question was, I have selection, which is words of, let's say, 0 to 2, and I do a console.write line of selection, sorry, selection of 0, and then I modify words of 0 to be something else, and I do again this selection, and I'm just gonna make it obvious in the output that okay, and uh, the idea, yeah, let's see what happens. So I'm just gonna invoke this, and run it, and I think I have a null dereference somewhere, so but I should still get the output. Takes a while. Now I can just put a break. Okay, so
Didn't change.
it didn't change.
Okay.
So I don't know.
Yeah.
Okay. Um, yeah. So in this case, I don't know exactly what happens. Anyway, it it's a good question. Cool. So thanks a lot for coming, and I hope it was useful. We'll put. I'll give you the links to the slides and the GitHub repo with which you can play. So you'll be able either to play with the Sharp Lab, and with the Sharp Lab, it's nice that all the code which is here, it's just encoded as a parameter to the URL. So if you start modifying, the URL will modify. So you can just open the snippets from the slides and then modify them, and nothing will break. So cool. Thank you.
Thank you. Any other questions? Any other questions? Yeah.
Yeah, so there's my question.
Yeah.
In the very beginning, when you presented the new features of C# 8,
Yeah.
you talked about static local functions.
Yes.
And you said, okay, yeah, it's cool because it's more lightweight and everything.
Yeah.
What I'm asking myself is, why can't the compiler figure this out itself? Do you know the reason why it can't just say, okay, we don't reference any of those fields anyway, so we can just use this form there?
I don't know. I'm pretty sure it does, so we can actually do.
Because yeah, it wants. So
Yeah, like, well, the thing is, the compiler, like, if So here you can see there's this private class, display class 00, with the number which gets captured, and if we just pass it now, the compiler knows not to generate the private class, so it's the exact same, let's say, functionality.
Okay.
However, I have x equals 2, and now I multiply with x, and now the compiler generates the internal class because
Yeah, now it needs it. So
it needs it.
Yeah.
And if I use the static keyword, it won't compile.
At least, yeah.
So the compiler was doing this before as well. I think having static local functions is just for us to help to not to introduce this sort of performance, by mistake, by when refactoring. If it's static, it's the intent is clear and the code won't compile. So, yeah,
Thanks.
you're welcome. Are there any other questions regarding anything from the presentation or?
So for me, it's also a question about runtime and compile time.
Yeah.
Is the recommendation still to keep this? Because typically when we are creating a class, we are passing parameters into that class, and we want to be sure that parameters are not null. So we'll add these checks. If parameter is null, throw null argument, no exception. So we have typically this, and this is checked at runtime.
Yeah.
So what's the recommendation now? Is the have up annotations plus have the runtime checks for the nullarity, or this can be removed?
I think it's keeping both. So the recommendations on the Microsoft all the documentation pages and the tutorials are to keep having defensive code. So keep doing null checks, and from when using public libraries which are not annotated. And also for the libraries, it makes sense. I mean, if we say, if the library says the parameter should not be null, it makes sense to throw an exception. If that's because the compiler will just emit warnings. So it's not like it won't compile. You can still pass null. So it's normal to be safe and to throw.
I think this is just for you to talk with. The compiler is asking you, what do you think you are doing? They said, I think this will not be no. Okay, I'll check for that.
Yeah. Yeah.
Because in the end, it's all warnings, right? It lets you
Yeah.
do all the mistakes
Yes.
same way.
Yes. But it's gonna be noisier. So it's
Yeah.
gonna give warnings. And that's what they say, even if with in the presentations and in the speaker notes there are on the nullability slide, I put in the speaker notes different links to documentation and to a channel 9 video, and you can and different blog posts, and they all say the warnings from the compiler are a helper, but they're not perfect. So the compiler won't know all the time when there's going to be a null dereference. And they also tried not to be on the false positive side. So they to reduce the noise, they won't warn. For example, one example they're giving is with multi-threading. So if if on a if if there's a field which, okay, you do a null check on a field, okay, if this field is null, but a different thread, well, not field, but property, a different thread might make it null, and the compiler won't complain. If you do a null check in the method, okay, you're doing your job, it won't work with complex cases like multi-threading environments. So, and you'll still, even if the compiler won't complain, even if you use annotations and the library uses annotations, you can still, like, code can still, our code can still throw nullable reference exceptions. So it's not a silver bullet, it's just a helper. It's a little bit the same with code analysis tools. You use code analysis tools, they help, but they're not, you know, if you don't get any warnings at analysis time, at compile time, that doesn't mean you won't have bugs in the code. The only thing is that using code analysis tools will reduce the possibility of having problems, and it's the same with the compiler. Basically, with all the nullability feature, everything that can be statically found at compile time will be found, and the number of bugs will be reduced, but they won't go away. Unless some years from now, the enforcements will be so strong that the compile time, the compile will fail, and people will be more forced to use this feature. But even then, in the case of multi-threading, the compile will know. So the compile won't fail, won't give warnings, won't fail, but you can still have nullable reference exceptions. So it's not a silver bullet.
And I'm still wondering about another scenario where it will be tricky to get normal checks right. It's probably deserializing something. So you get a JSON string, and you're trying to deserialize it into. You had an example with customer and address, right?
Yeah.
You have a customer who have address, and the address has a street, for example.
Yeah.
Yeah. So, for example, if you make address non-nullable, and you are deserializing from JSON, and there is nothing for the address, so nothing will prevent you put a null value in the address. And nothing will prevent it throwing runtime exception later when you're trying to access address.street.
Yes, exactly. But this is a case where if you know, I mean.
So how we will prevent, for example, in this scenario when we are deserializing something, how we will prevent it happening?
Well, if you deserialize it and there isn't some sort of layer of making sure, you can always make a wrapper or a helper deserializer, which before, like a layer before any user input in your program, that makes sure that anything after that layer will be validated. It's the same with any kind of validation for any kind of input. It's the programmers will have to do it, because in this case, if you declare that address should not be null, and uh, then you create this object by deserializing from JSON or from basically user input, it means you're not really declaring the intent and the possibilities correctly, because if it's going to come from user input and there's no validation.
It may come from a different external source, but probably you're right that this had to be explicitly validated. By and the constraints of the model has to be verified at runtime. So it's not enough to declare it during compile time, but you have to also verify it at runtime. Every time you access something.
Yeah, exactly. The only thing is that after you verify it, you know that, and you have this verification layer, you know that in your program, which is just on your side, you won't have null. And wherever it's going to be used, you won't need to null check everywhere.
Okay.
Yeah.
Any other questions?
I'll just comment about this annotation type. I think it's really confusing in the end, because it's up to the developer to pick the right annotation.
Yeah.
So developers were creating ergs naturally. Now they will also create noise because the annotation that they will pick will generate more or less warnings on other developers' desktop. So I mean, it's really confusing in the end.
Especially until everything will, I mean, especially until everything will be migrated and all libraries will be properly annotated. Yes, it will be noisy and there will be a transition period for everybody to get used to it. But it's kind of the end goal, like 5 years from now, .NET development will be safer from a null reference point of view. But until then, it's going to be a learning curve, including for Microsoft, which considers this is why it's disabled by default. This in .NET Core 3.0 and in all .NET, all the frameworks that support C#8, it's disabled by default, and they say that they consider this in sort of a preview mode, and they encourage people to start adopting it and provide feedback. And Microsoft itself, they said that they only annotated 20% of the core libraries, of the .NET Core libraries. So it's a learning curve for them as well, and they ask the community to start adopting the feature so that they can tell what the problems will be. And another thing that is gonna be confusing is with generics, because on a type, on a generic type, you can't put say that the generic is nullable. That's another thing that comes up in the, let's say, discussions. So I think that there is some I forgot, yeah, where I don't remember. There was some sort of meta information, but you can't, yeah, you can't use this with generic types. So it is, it's gonna be a confusing, let's say.
It will also impact the compilation time.
Uh,
If you have tens of libraries that have only partially adopted this, this new notation.
Yeah.
So yeah, I mean, it's really confusing so far.
But I think worse than that, the nullable, I think it's the templates on the interfaces. You have people, you're having this diamond problem.
Yeah, for the default interfaces.
Yeah, for the default interfaces.
So what?
Because the nice thing of the interface was
I will stop recording.
Yeah.
We will continue discussion later. So thank you very much for coming. Thank you very much for the presentation.
Yeah, you're welcome. My pleasure.